Hello students, this video lecture is prepared for heat transfer subject and I will discuss the unit number 4, that is condensation and boiling. So in a previous lectures I had discussed about the correlations of pool boiling. Then today I will discuss how to solve the problem on that correlation. So these correlations we had discussed in a previous lecture. So this is applicable for nucleate saturated pool boiling. And now I will discuss the problem which is based on that correlation. So I will read this problem. Water is boiled at atmospheric pressure at the rate of 30 kg per hour in a copper pan of diameter 30 cm. Determine the temperature of the bottom surface of the pan assuming nucleate pool boiling. And the data is given as the properties of water at atmospheric pressure are Ts, that means saturated temperature 371 Kelvin, rho L, density of liquid 957.9 kg per meter cube, CPL, specific gravity of liquid 4217 joules per kg Kelvin, mu L, viscosity of liquid 27.9 in 10 to the power minus 5 kg per meter second, Prandtl number liquid 1.76, lambda, latent heat of vaporization 2257, then sigma means surface tension 5.89 into 10 to the power minus 2 Newton per meter. Rho V, density of the vapor 0.59955 kg per meter cube, and CSF, that means surface water combination constant, is equal to 0.013. Okay, so this is the actually problem given in your book. So first we will discuss the problem, or first we will understand the problem and then we will go to the solution. So the water pan is boiled at atmospheric pressure. So this pressure is atmospheric pressure at the rate of 30 kg per hour. So this is the mass flow rate of that water, and it is boiled in a copper pan. So this is the pan actually. So this pan is made from the copper and it is having diameter 30 centimeter. So this diameter it is having 30 centimeter, and we have to determine the bottom surface of the pan assuming that nucleate pool boiling. So suppose the nucleate pool boiling is taking place in this pan, copper pan, and we have to calculate the bottom surface temperature, that means this temperature. Okay, so here the heat is given to this copper pan, the water is boiled and the nucleate boiling is assumed. For that purpose we have to calculate this surface temperature. So what is the surface temperature at the given condition? Then we will move to the solution. So this is actually formula for the calculation of that surface temperature, and it is also useful for nucleate pool boiling. So what is the formula? We have discussed earlier. CPL into TW minus TS divided by lambda is equal to CSF into square bracket q by a mu L into lambda multiply by under square bracket sigma divided by G into bracket rho L minus rho V. Square bracket complete and whole bracket is having the power 1 by 3 multiply by Prandtl number to the power n. Okay. So we have to put the values here and then we have to calculate the surface temperature. So let us assume that TW minus TS is delta T. Suppose instead of this parameter we can write the delta T here. And then we will calculate first delta T. And after that by putting the value of saturation temperature we can calculate the TW value. So first we have to assume that this value is delta T. Specific heat is also given in this problem. So you have to put this heat. Then this is the delta T as it is. Then you have to write the value of lambda. So this we have to convert into the joules per kg multiply by 10 to the power 3. So left hand side is over. Then CSF is nothing but the surface liquid combination. So here the surface is copper and the liquid is water. So the CSF is given as a 0.013. So that is you have to mention here. Then Q by A. So this value does not given. So that value we have to calculate first. So what is Q by A? Q by A is nothing but the heat flux. So how the heat flux is calculated? You have to just write the that mass flow rate multiply by this lambda divided by area. So Q is nothing but m dot lambda. So what is the formula for Q? M dot lambda, and area we can calculate as a pi by 4 by d square. Okay. So m dot is 30 kg per hour. So that we have to convert into the second. So 30 divided by 3600. Then again you have to convert that lambda 2257 multiplied by 10 to the power 3. Then area of that copper pan is given as a pi by 4 d square. So here this is the diameter and that diameter is converted into the meter. So 0.30. So pi by 4 d square. So if we calculate this value, we will obtain this value 266083.5 watt per meter square. So this is the value of Q by A, which is not given in a problem. Okay, so you have to just calculate from the mass flow rate and latent heat of vaporization. Then you have to put this value here. So you have to put this value here. So we have already put here. Then mu L, that means viscosity of liquid. So this is the viscosity. Okay, so you have to write as it is because this is the SI unit, kg per meter second. So there is no necessity to convert viscosity unit. Then lambda. So that lambda we have already discussed here. This is the lambda. So put as it is. Means after conversion joules per kg you have to put here. Then under square root you have to write the sigma. So sigma is also given in a SI unit. So what is sigma? Sigma is nothing but surface tension. So surface tension is already given as a 5.89 into 10 to the power minus 2 Newton per meter. Then G is acceleration due to gravity. So it is having value 9.81. So this is the constant 9.81 meter per second square. Then density of liquid. So this is the density of liquid 957.9 kg per meter cube minus density of vapor. So vapor density is also given here 0.5955. Okay, and whole bracket have the power 1 by 3. Multiply by Prandtl number. So Prandtl number value is also given directly here. It is not necessary to calculate. 1.76, and we have already discussed that this n is nothing but the power, which is equal to 1 for water and 1.7 for other liquid. So here we are using the water for boiling purpose. So just we have to take this power to the 1. Then calculate left hand side and then right hand side and solve this equation for the delta T. So the delta T is equal to 12.5. So after calculation of all these things, we get the delta T is equal to 12.5. And we have assumed that delta T is equal to TW minus TS. Okay. So we know that delta T value. We know that TS, that means saturation temperature of water. So it is equal to 373 Kelvin. So if we take this TW this side, so TS plus TW, so it will become TS plus TW. Sorry, delta T plus TS. So delta T we are having 12.5 and TS means saturation temperature 373. So you have to just add these both of values. Then we get 385.5 Kelvin. Okay. So what is TW? Is nothing but it is the temperature of the bottom surface of the pan, which is equal to 385.5 Kelvin. So this temperature is TW, and saturation temperature is already 373 Kelvin. That is boiling point of water. Saturation temperature is nothing but the boiling point of water. So it is also given in the problem 373 Kelvin. So you have to just calculate the value of TW, and which is the answer of this problem. So question is that determine the temperature of the bottom surface of pan assuming nucleate full boiling. So in this way we have calculated the TW, that means temperature of the bottom surface of the pan is equal to 385.5 Kelvin. So this temperature is 385.5 Kelvin. So obviously it is a higher temperature than saturation. So in this way we can solve this type of a problem. Then there is another problem for the critical heat flux. So that we discuss in a next lecture. So today's lecture we have discussed only the exercise which is based on how to calculate the TW from these correlations. The remaining part we will discuss in the next lecture. Thank you.